next up we have just a refresher on the types of collisions. We already talked about this a little bit, but number one, we have elastic, Ke conserved, and momentum. That's the first type. The second type is inelastic, which is only P. And the second time is we have perfect, or the last one is perfectly inelastic. Again, only P conserved, but just it's still easier to calculate it in this type because the final velocities are the same. And now we're talking about momentum here. Before we were only thinking about it as linear momentum, but it's also applicable to angular momentum, and it's the same type of idea as when like disks collide and rotating objects collide that are rotating with a certain angular momentum. It's also conserved always here, and the kinetic energy is only conserved during elastic collisions. So that being said, let's just look at problem number 17, which has to do with two disks who are rotating and then collide. So we have first disk, and there's a second disk. The first one is still, and the second one is rotating, speed w. And then 17 asks, like, what is conserved after this disk is dropped onto this disk, and then after a while, this disk slowly slows down to a in the middle speed. And this speed is like on top of it too. They're both rotating at the same speed. And this is a perfect example of a perfectly inelastic collision. They stick together and they basically rotate at the same speed. And we know that in a perfectly inelastic collision and all inelastic collisions, angular momentum is conserved but not kinetic energy. So the answer choice is B.